Casey, I'm assuming you can hear me online? Yeah? Okay, good. Wonderful. Oh, yeah, we're time. Okay, let's get going, I guess. Okay, so first things first here. So dealt with that practice exam yesterday, and got them all graded. I wasn't sure I'd be able to, given I did it for all three of my classes, but let's be honest, it doesn't take me long to look at a couple of quadratics and a quick graph for everybody. So I got those all taken care of. Some general comments here about this, folks. So first of all, um, that's okay, Brent. That's okay. It happens sometimes. Um, so, um, so I lost my train of thought there. So, yeah. So first of all, you should be able to find them over, if you go into My Grades over on the Blackboard stuff, and should be, click on that. You should be able to click on, I think it's supposed to show up. The option that I've kind of got selected is it shows up when everybody is done graded. So I think they're going to be there. If they're not there, holler and I will go kick the options to make them show up. Okay, so but I think they should be there if I've got my options set correctly there. But this is kind of the first time I'm doing this, so this is kind of new for me as well as you guys. Um, so for most of you, there aren't any comments on. There's a handful of comments I put on there. But if there are comments, if I understand correctly, there should be a little blue kind of comment icon next to the score you can click on to catch your comments, okay? If not, I think while you're in the My Grade stuff, you can click on the actual exam itself, and that'll bring up a more detailed view. I think the comments should show there as well, okay? But again, I think they're supposed to be there. If not, let me know. But like I said, most of you don't have comments on this. Regular exams, pretty much everyone's going to have a comment on it. Okay, but for this one, I didn't put any comments on, so I can get through everyone a little bit quicker. Now, the next thing here, folks, is that I didn't actually grade this in the sense that some of you had some mistakes on it. Simple, basically kind of not paying attention to minus sign mistakes, that kind of thing. Basically, I graded it as long as you did it, okay, and turned something in. So I didn't want to hurt your grades. Right? So you got 5 points. Now, having said that, there are a couple of you, and every class is in every class. I'm not picking on any particular person in this class or anything. But a couple of you turned it in late, and I warned you all what was going to happen about that. Those got no points, okay, because you had 12 hours to do it, and I always kind of made it clear it was going to happen if you turned it in late. So no points on that, okay? And not to be ugly about that, but I don't feel a lot of sympathy for that. You did have 12 hours, okay? So I suspect most folks who turned in late simply forgot about it, to be honest, okay? So be aware of that fact. But if you did it and got it into me on time, i.e. by 7 o'clock last night, I accepted it as correct. And again, just gave you 5 points for turning it in. Okay. Now, one of the reasons for going through this practice exam is for you guys to know how things work, but it's also for me to figure out where the problems are going to be. Okay. And so I come in and talk about it the next day. So I'm going to go through a couple of things that came up through some emails and whatnot. And pretty much every class, I got emails from pretty much every class about this stuff. So again, not identifying any one or two people on this type of thing. If you were the ones who emailed me this kind of thing. And every class pretty much had the same issues here. First of all, that app that I was kind of, I don't say pushing, but the app that I keep mentioning, Cam Scanner, it is free, folks. Okay, I had some folks kind of freaking out about it, having to pay for it. It's like $50 a year or something. It's really expensive. Okay, but for what you guys need to do, the free stuff works. Okay, there's some premium stuff you have to pay for. You don't need it for this class. Okay, all you need to be able to do is to take pictures, combine them into a single PDF, and then email it to yourself and upload it from there, or just log into Blackboard from your phone and upload it from your phone. One of the two. Okay, and that's all the free stuff. So you do not have to pay for it. Okay, so please don't think that I'm making you guys use something you have to pay for like this. It's definitely not the case. Okay, so be aware of that fact. Now, the next thing here, folks, and again, I had some folks kind of getting a little panicking about this, and I get that. Blackboard apparently has changed some stuff on me. Last time I did this, when COVID first hit, it would allow you to upload multiple files, and apparently it's not doing that anymore. You can upload exactly one file, okay, which is convenient because given that's what I asked you to do anyway. Okay, just upload one file. But I did get some folks who either put problems on separate pages or wrote really big, and so they had really big graphs. So they had 2 pages of or something like that, and they were panicking because they didn't use the app that I had, which you don't have to use again. But they didn't have it in one file, and then they couldn't upload all their files. Yep, right, because Blackboard wouldn't let it. So again, one of the reasons that I kind of like that Cam Scanner app is it does that automatically for you. Right, so again, I'm not pushing it, say you have to use that, but it does do what you need to do for what I'm asking you to do. Right now, for those of you who had that issue, of course, either use Cam Scanner or figure out the app you're using if it'll do it for you. Okay, so because some will do that, it may not be obvious to do it, but some may do it for you anyway. But again, come exam time, you need to kind of get that figured out at some level, folks. Simply because that's something you don't want to be messing with during the exam. Okay, you want to be able to upload your single file during the exam. If you had practice exam, you had plenty of time to panic about it, try to get it fixed up and whatnot. But during the exam, you ain't gonna have that kind of time. Okay, so if you don't want to use CamScan, that's fine. But if you had some issues with that, oh please tell me it's not stuck. Oh, it's screen. Yeah, I'm sorry. The screen should. Yeah, it's stuck. I ain't doing anything. I'm not doing anything. So yeah, screen should be stuck, or apparently stuck. Yeah, I'm sorry. I was thinking maybe the sound was stuck again. So, but no, I'm not moving anything. So there it is. So moving now. Anyway, back to this stuff. So if you're not using Cam Scanner, folks, just make sure your app can do that. And that's going to be true for a lot of you, because a lot of you wrote small enough to get everything onto one piece of paper, which is fine. Your exam, of course, you will not be able to do on one piece of paper. Yeah. Okay, so you're going to need multiple pieces of paper, which means multiple pictures. So if you're not using that Cam Scanner, even if you are, geez, don't tell me the sound is going again. Can anybody else hear me, or is the sound out completely? Scrape the sound is out. Okay, yeah, Jordan, maybe you need to refresh there or something. Yeah. So if it's just on your end, you probably need to refresh on your end. So I was going to be upset if the sound was going out again for everybody. Okay, but back to this stuff. So, Cam Scanner or not, folks, make sure you get your files into your pictures into one file. Yeah, because Blackboard's going to insist on a single file. Okay, so please be careful with that. So again, if you just uploaded one, so if it's just one, sorry, if you did just one picture on this one, just take a couple of pictures of stuff on your desk or something and make sure you can put them into a single file. Yep. Okay. Again, just like I said, you don't want to be messing that during the exam, because again, folks, this is kind of the point of the practice exam, is to figure out where the problems are going to be. Because I'm going to be just as much of a jerk on the regular exam as I was on this one. If you turn in late, I don't take 0 points. Okay, so get those issues all, make sure you can get those all sorted out. So like I said, just take a couple of pictures of something on your desk and make sure you combine it into a single file. Okay, so there is that stuff. Okay, all right, that's taken care of. All right, now at this point, I guess let's continue on here, folks. So if I remember right, homework is due Friday. Yes. Right, makes sense. Yep. Okay. So homework due on Friday. So we'll do a help session tomorrow, which again, I'm assuming is going to be mostly dealing with trig substitutions, but that's okay. All right. So let's go ahead then and do a couple more partial fraction problems, just so we can say we've done a couple more of these things. So let's take a look at this one here. So again, being careful with those degree things again. Remember, we can technically only do partial fractions again if the degree of the numerator is strictly less than the degree of the denominator. Yep. Now, degree of the numerator is pretty easy to see. That's just a 3. So degree 3 on the denominator. I'm sorry, on my numerator there. Denominator is easy too if you think about it, but be careful. Yep. So first of all, the degree of the denominator is not 2. Yep. That's the highest power here, but it's not the highest power in the denominator. Yeah. If you were to multiply this thing all the way out, which you don't have to do, of course, but if you were, you've got an x squared here. So this term's going to pick up an x to the 4th, right? And then x to the 4th is going to be times an x here. So the highest power in my denominator is going to end up being x to the 5th if we multiplied it out. Yep. Again, we don't have to, but we kind of eyeball what it's got to be. Again, x squared, x to the 4th, x to the 4th times an x, so x to the 5th. Yep. Okay, so 3 is pretty clearly less than 5, so I can do partial fractions on this problem. Now, my next example, that will not be the case. Okay, so we'll show you how to deal with it if the numerator is not smaller degree than the denominator. But that's next example. Okay, so this one a little bit unpleasant, folks. Okay, so let's get started on this one. See how far we get into this one here. So, oops, is that doing that to me? There it is. Okay, sorry about that. All right, so let's go ahead and do our partial fraction decomposition here. Like I said, this is definitely an unpleasant problem here, folks. So write this down again just to get us started off here. There we go. All right, so I've got this linear term here. So again, my table for up the top up here. Let's scroll all the way back up one more time here so we can see our table. Oops, there it is. So there's our table. Yep. Okay. So again, linear term to the first power. So we'll pick up one of those. But the important part, folks, is that quadratic is squared. Yep. So it's an unfactorable quadratic to a power squared. So I'm going to pick up two of these things in. Yeah, one for the first power and one for the second power. Yeah, which is part of what makes this problem so unpleasant. I'm going to deal with two of these things. Okay. So, all right. So let's go ahead and scroll down. There we go. Okay. So there's my linear term. So a over x minus 1. There it is. And then quadratic squared. So I'm going to pick up two of those terms. So a bx plus c over x squared plus 4 to the first power. Yeah. And then plus a second one. So dx plus e over the x squared plus 4 squared. Yep. Again, one for each power. Yeah. And I mean that again quite literally. I don't mean put it down twice. Again, I mean one for the first power, one for the second power. Okay. All right. Now, at this point, I'm already kind of shuddering a little bit because I see 1, 2, 3, 4, 5 unknowns here, which means I'm going to have 5 equations, 5 unknowns eventually. Yeah. Right. So, so I already know it's going to be somewhat unpleasant. Yep. Okay. So, least common denominator. And so again, let's just be careful. Step back for a second. Set our numerators equal. Yep. And to do that, we need least common denominator. Right. So, again, keeping in mind the least common denominator is not this times this times this. That would give me an x squared plus 4 cubed. Not what we want. We want the x squared plus 4 squared because again, the two denominators need to be the same. Yeah. Right. So here's my numerator over here. So write that down quickly here. It is. Okay. So again, quick way of doing this. Yeah. A times what's missing? Well, again, what's missing is both of my x squared plus 4s. Yeah. So there it is, x squared plus 4 squared. Okay. Bx plus c times what's missing? Well, I'm missing the x minus the 1. Okay. And I'm missing one of the x squared plus 4s. So there we go. And yeah, this is going to happen here. This down here. So last term then, dx plus e times what's missing? Well, in this case, we're just missing the x minus 1. Yeah. Okay. Everybody agree with my numerator stuff there? Yeah, good. Okay. Online, you guys doing okay with that? Everyone agree? Yep, good. Okay. Now the pain starts. Yep. Dx plus c. Talk about this one here. Here. Oh, I'm sorry. That's supposed to be a 10x squared. Sorry. Yeah, I'm trying to write in a hurry, so I get myself in trouble. Stop doing it again. Plus 10x squared. Sorry about that. Yeah, thank you. Yeah. I would have caught it eventually, but better to catch it now than later. Okay. So, yeah, folks, again, the trick I've got here, I mean, we could use the trick x equals a 1. It would knock the second and the third term out. I'd get a. That's it. Yep. Right. So the trick ain't going to work for anything else. So basically, we're stuck here. We're going to have to multiply this thing all the way out. That's just not going to be pleasant. Right. So let's go through and do the work. Now, to do that, first thing here is this bit up here. Yeah, let's multiply those two together. I'll do this off the top up here. Then we'll have to multiply all that times bx plus c. Yeah. I multiply these out. What do we get? Looks like I'm going to have an x cubed minus an x squared plus a 4x minus a 4, I guess. And again, all that again is going to be multiplied by the bx plus c eventually. Yeah. Okay. So let's see here. Down here. Okay. A. Square that out. So x to the 4th plus a 16x squared plus a 16, I guess. Yep. right? I hope. Plus bx times all that stuff. So b x to the fourth. Go minus a b x cubed plus 4bx squared minus 4bx, I guess. Yeah. That look right? I agree. My ability to do that. That looks right. Yeah, it's running out already. It's going to happen. Throw down here. And then C times all that stuff. So again, save us a little bit of space here. So C times all that stuff. Okay, there we go. And then the last bit here again is dx plus an e. Sorry, erased half of that there. Put that back up again. Screw it up. There we go. Okay, so dx plus e times x minus 1. So what we got here? So dx squared minus dx plus ex minus an e, I guess. Do you all agree with that? Find out here in a minute where I screwed it up. So we'll hold it up. Okay. So, all right. Now, at this point, folks, again, I got to stress enough again, folks, it's just these are painful. Take your time. Yeah. Try not to hurry too much on these things. They are really easy to screw up. Okay. All right. So, take our A, distribute it through. Take our C, distribute it through. Combine up all of our like terms. Again, kind of marking off as we go. Okay. So, we can be careful what we're doing here. So, it looks to me like x to the fourth are the biggest terms. You can have an A from the first one and a b from there. Yeah, so a plus a b, x to the fourth. Go ahead and kind of mark them off as I go here. Yeah. Okay. X cubed terms. Nothing in the first setup here. I see one sitting right here, so minus a b from there. I'll mark it off there in a second. Multiply a c through there, so pick up a c there. Oh, so that's about it. So it's like two x cubed terms. Yeah. So that one and that one. Yeah. Okay. X squared terms, 16a from there. And then a 4b from there, it looks like, yeah. There we go. Minus c from over here. Looks like there, and then a plus d from there, it looks like. So we can't fall off it. 16a, 4b, minus c, and a plus d, yeah. Okay, I agree. Yeah, all right, let's go down the line again. Like I said, an unpleasant problem here. Do our x terms now. So, x there, pick up a minus 4b from over there. There it is. Pick up a 4c from there, it looks like, yeah. Go, and two x terms from here, a minus d and a plus e. So minus d plus e. X. Mark them off again. Careful. So there's my x there, there's that one, there's that one, there's that one. Yep. Okay. Last but not least then, constant terms. And then we're done with at least with this part of it. 16a there. Okay. Minus a 4c from there. And a minus an e from there. Yep. Go. Again. Off, so I know I've got everything. And there we go. As unpleasant as it is, there it is. Yep. Again, these are long problems, folks. What I will tell you right now is homework. Yeah, you might see something like that on the homework. I would make sure that if it ends up being 5 equations, 5 unknowns on an exam, it'll be a lot simpler than this one. Okay. And even there, I think 5 equations, 5 unknowns is probably too much for exams. Okay. But trust me, I can keep these things so they're actually quite simple. Okay? If I hook them up properly, set them up properly. So basically, homework messy like this, exams, I will definitely try to keep a partial fraction problem on the exams a lot simpler. Okay, so don't be freaking out about that kind of thing. Okay, now at this point, folks, we have to set our coefficient sequence. Okay, so we'll just start with x to the fourth. I tend to start with the highest power. So again, and I'm gonna have to scroll up here. Remember what we're trying to do, yeah, is get A, B, C, D, and E so that this horrible mess here ends up being this thing sitting up here, yeah? Okay, that's what needs to all equal to. So underline that to make it clear. Yeah, that's what I have to be equal to. Okay, so a plus b. Well, x to the fourth, there is no x to the fourth over here, so my a plus b has to equal to 0. Yep. My x cubed terms. Okay, so again, x cubed. Let me flip the order there just so I don't lose the minus sign yet. So c minus a b. Again, just kind of said keep from losing the minus sign. I see the x cubed over here has a coefficient of a 1. So my x cubed over here has to be equal to 1 for my coefficients to match up again. Yep. X squared. So what we got here, it's getting a little bit messier now. So 16a plus 4b minus c plus d. And my x squared up here looks like I got a coefficient of a 10. Yep. So this x squared here has to equal to 10. X to the first power, again, a mess, but there it is. So minus a 4b. Yeah, Casey, yeah, we'll get there in a second, but yeah. So minus 4b plus 4c minus d plus an e. There we go. Okay, so linear term up here, x is just a 3, and while I'm at it, note the constant's a 36, and I'll scroll back up. Yep. Okay, so my what I just got wrote down has to be a 3, and then my next one's going to have to equal to 36. So equals 3, and then my constant terms, which again I write as x to the 0. Yep. So x to 0. Again, there it is. So 16a minus a 4c minus an e, and again that has to equal to our 36 from our thing up above. Yep. Okay. Now, again, folks, 5 equations, 5 unknowns. Okay. Again, these are messy. Okay, but they're not again as bad as they can be. So, as Casey pointed out here, yeah, I can simply take my first equation and say either a is equal to minus b or b is equal to minus a. Take your pick; it doesn't matter. Okay, I'm going to go with a equals minus b, kind of just talk our way through this. So, a is minus b for my first one. Yep. Also, with the second one, notice I could do the same thing for this one here. Yeah. If I added b to both sides, c is 1 plus b. Right? So I've just written a in terms of b and c in terms of b. So I can take those down here. So that's not an a, that's a minus b. That's not a c, that's a 1 plus a b. Yeah. Same thing there. That's a 1 plus a b. That's a minus b. That's a 1 plus a b. Yeah. So by doing that, I can take these bottom 3 down here and write them as 3 equations in terms of 3 unknowns. Okay. Make sense, everybody? Yeah. Also notice with this last one then, yeah, I wrote a in terms of b, I wrote c in terms of b, so now I've got an equation down here in terms of only b and e, yeah? So now I can solve, say, for e, so e equals 36, whatever the b works out to be, okay? So I can solve this one to get e in terms of b. Now I've got these 2 equations up here just in terms of 2 variables, okay? Looks like probably a c and a b maybe, if I did my work right. Yeah, not a c and a b, sorry, a d and a b. Okay, so at that point, you're now down to 2 equations, 2 unknowns, and you can solve. Okay, so again, I know these look messy, folks, but again, you can always quickly reduce them down. Okay, so just kind of keep that in mind with these things. I will never get you a set of 5 equations, 5 unknowns, where every equation has all 5 unknowns. Those would take us, I don't think how long it would take to solve, but it takes a long time to solve. Okay, but with these kind of systems here, folks, and the partial fractions will always have this kind of setup in. Okay, you'll be able to use 1 or 2 at the top just to quickly reduce things down for you. Okay, and I can set these up again where they're actually even a little bit easier again if I'm careful with how I set my problems. Okay, so just be aware of the fact that they're not as bad as they look. Okay, so I'm going to suggest again after class, go through the work, make sure you get the answers I got. Okay, so A is going to be a 2, which means B is going to be a minus 2 since A is equal to minus B. Or the way around, okay, we'll think about it. And then C is going to end up being a minus 1. D is going to end up being a plus 1. And E is going to end up being 0. Okay, now, just like I said with the last example, folks, when you get in equations, messy equations like this, I will make sure the answer is at least exam-wise going to be very nice. Okay. Again, web assigned, I'm not sure how nice they're going to be, but even there, they're not going to get too messy for these kind of problems. Right. So again, yes, messy. Answers should be nice. Again, if you end up with a 3-digit or a 4-digit fraction over here, you've made a mistake. Find this, okay, before you start having to write all that stuff down. Okay, so next comment I want to make real quickly is I'm not going to get excited about that e equals 0 term there. Or better yet, I am going to get excited about it, but in a good way, right? In the sense of I couldn't say ahead of time I knew one of these constants was going to be 0, but having one of these constants end up being 0 just simply means one less term I'm going to have to deal with in my integral. Okay, so when if you get the occasional 0, that is not a problem. Right? In fact, it's a good thing because it means, like I said, one less term you have to deal with. Now, if you end up getting a bunch of zeros, go back and start thinking about where you made a mistake because you probably made it. Right? I can't imagine these problems being any more than one big 0, and most of them you're not going to get any of them being 0. But occasionally, if you get one of the coefficients being 0, don't worry about it. Okay, so can happen. Definitely liking this problem as well because it'd be really hard otherwise if that e is not 0. So, all right. So let me go ahead and plug everything in here. So start my integral. Write this down again. This stuff. All righty. Equals. Okay. So I'm not going to scroll back up, but a was over the x minus 1. So 2 over x minus 1. Plus, it was bx plus c over the x squared plus 4. So plus and minus 2x minus 1 over x squared plus 4. Yeah. So yeah, sorry about that. Okay. And then the last one, it was e or dx plus e over the squared term, but e was 0 again, d was 1, so just x over x squared plus 4 quantity squared. Don't forget that squared there, yeah? And then dx. Okay, so plugging everything in, trying to be careful with that. That's what we've got. All right. Now, let's do a little bit of a rewrite here, okay? First term I'm confident y'all can do. Leave that one alone. This second term here, right? This one, folks, is like, right? We saw one the last example, right? Similar basic idea. An x plus a number over a quadratic down there. Yep. Okay. Which also means that eventually, keep scrolling back up here, I'm going to have to use that formula there. This eventually. Okay. So how do we do it? Well, just like we did for the last example, right? I could do a substitution x squared plus 4 if I had just the 2x, right? If I don't have this minus 1 or this 1 up here, means I can't use that substitution. On the other hand, if I didn't have the 2x term here, I could use that formula that I just had up there. I'll mind you what it is here in a second, okay? Because I know I scrolled past it pretty quickly. So basically, just like with the last example, folks, when you see something like this, okay, you've got to split it up right there. You don't have a choice, okay? So let's split it up. So minus 2x over x squared plus a 4, yeah, minus 1 over x squared plus a 4, okay? Here again, I can do a quick little u substitution, x squared plus 4. That's exactly what I need for my substitution to work for me, 2x. Here we can use that inverse tangent formula we had up above because it's just a constant up there, okay? Now, just to make it obvious here, folks, again with this one, maybe write that as x squared plus 4 to the minus 2. Yeah, to make it a little bit clearer what we got to do for that one. And so for this one here, again, all I need to do for both this one, I can do u equals x squared plus 4 then for that one and for that one. Yep. Yep. Everybody agree with that? Everybody follow? Good. Okay. And of course, this one here, I can clear again. This is just going to be that inverse tangent business. So I'll write all this down here in a second. Okay, so there we go. So in fact, let's go and write it down. So first one again, 2 natural log absolute value x minus 1. Again, be careful with your absolute value bars for WebAssign, folks. It's going to be expecting them when they need to be there. Don't put them in. It's going to yell at you. Okay? All right, minus, and then again, just u equals x squared plus 4. Again, dx is exactly 2x. So that's exactly what I need for this. So upon my substitution, yeah, this becomes a 1 over u. So minus natural log of u, and u being that x squared plus 4. Yep. Okay. There's that one. And then minus. Now, again, remember, for my formula up above, it was x squared plus a squared. So for my formula, put it in up here. So again, there's my inverse tangent formula using a equals 2. Yep. Because a squared is equal to 4, so a has to equal to 2. Right? So my formula then is 1 over a, so 1 over 2. Inverse, or again, arctangent, it's probably best to use arctangent for WebAssign. So inverse tangent, or again, pick what you want to use. Yep. And then x over a, so x over 2. Okay, that makes sense, everybody? Well, provided you remember the formula and whatnot. So, yep. Okay, last term. Now again, u equals x squared plus 4. Yeah. So du is a 2x. I'm missing the 2 this time, so I'm going to pick up a 1/2. Yep. So pick up a 1/2 there. Now this just ends up being u to the minus 2. So integrate that to u to the minus 1. So x squared plus 4 to the minus 1. Divide by the minus 1. So change that plus to a minus sign, I guess. Yep. And plus c. Not going to stay simple. It's going to say there it is. It's done. Yeah. Right. Because it ain't simple. Okay. Folks, for the most part, this one is probably way harder than anything I would, again, definitely harder than anything on the exam, right? And anything on the website stuff is not going to be any harder than this one. This kind of encompasses everything that we need to know how to do, okay? That's just from that formula, yep. When you integrate something like this, yeah, you get either the inverse tangent or the arctangent. So that's just using the formula there. Yeah, and the arctangent, yeah, the arctangent is just tangent to the minus 1. Yeah, remember, they're just alternate notations for the same thing. Again, it's easier to do arctangent for WebAssign, type that in than the minus 1. It's easy to mess up the exponent in WebAssign. So, yeah, just they're alternate notations for exactly the same thing. Yeah, misunderstood your question, I think. So, okay, anything else? Okay, so no questions on this before we move on to the last one in this session. Okay, so space it, there it is. Okay, first thing to notice, degree of the numerator is 4, degree of the denominator is 3. Partial fractions won't work, or at least won't work with it written as is. Yeah, okay, so and again, to make it kind of clear here, it won't work because it's x to the 4 divided by x cubed. Yep. Again, 4 being bigger than 3. Yep. Okay. So, all right. Now, what that means for us, folks, is it doesn't mean we can't do the problem. Obviously, it's here so we can do the problem. Right? But what it means is you guys having to know something that I don't think they even teach anymore, unfortunately for you guys. Okay. And this is really unfortunate because it doesn't come up often, but you need it here. There's this thing called long division out there in the world. Okay. You probably saw long division back in, say, high school algebra class somewhere. Okay. The problem is they don't teach long division properly anymore. All they do is they teach this business called synthetic division. The problem with synthetic division, folks, is it doesn't always work. And guess what doesn't work for this problem? Synthetic division, right? So you have to kind of know how to actually do long division for this problem to work. Okay, so what we're going to do, let me get my numbers out so I got to sit in front of me. So here's how it works. Okay, so excuse me, I'm going to take my numerator here. Yep, write that down. There it is. We're going to divide it. So there's our division symbol. Yeah, from that fancy division symbol. You don't see that terribly often these days, but there it is. You divide it by the denominator. So sit down in front. X cubed minus 3 x squared. Yep. Okay. Now, again, you can, if you did learn that synthetic division stuff, folks, it just simply won't work here. Synthetic division requires you to divide things that look like that, x minus a. That's it. Right? So without that, and clearly we don't have that here, synthetic division will not work. Okay. So what we do here, is we ask ourselves then, this thing here times what gives me x to the 4th? Just the first term. So all I care about is the first term here for a second. Okay. So I've got this x cubed sitting out here. So I'm simply going to ask myself, x cubed times what gives me x to the 4th? That's hopefully pretty obviously an x. Yes? Okay, so put the x up there. Okay, so that's going to be x times all of that stuff there, all of it. Yes, I asked just the first term. That's all I care about. You still have to multiply everything by the x. Okay, so x to the fourth minus the 3x cubed. Yep. Okay, and take that, subtract it off. Yep. So what do we get here? So I get x to the fourth minus x to the fourth. That's 0. I'm not going to write that down. I got a minus 5x cubed plus a 3x cubed. Yeah. Okay, so minus 5 plus 3 there. So minus 2x cubed. Yep, good. And watch your minus sign there. So it's going to be a minus sign still. So minus 2x cubed. That minus coming in, of course, from that thing there. Yep. And now technically, there's no x squared here. So 6x squared minus is 0x squared. So plus 6x squared. Minus 18 minus 0. So minus 18. Yep. So basically, the terms that don't have any corresponding term down here, you just kind of basically take and write them straight back down. Okay, do the same thing. I'm going to ask myself, x cubed times what gives me a minus 2x cubed? Well, again, fairly obvious, I hope. Minus 2. Okay. Okay. So take the minus 2, multiply it through here. So minus 2x cubed plus 6x squared. Take that, subtract that off. Okay. So a minus 2x cubed plus a 2x cubed, 0. Yeah, distribute your minus sign through. 6x squared minus 6x squared. Hey, that kind of works out nicely on the 0 as well. Okay. What's left then just is 18 minus 0, so a minus 18. Again, just don't lose track of your minus sign. Okay, y'all follow the steps up to this point? It's just basic algebra. Okay, but again, like chances are you guys never saw this actually taught anymore, which is unfortunate. Okay, so okay, now when do you stop the process? You stop the process when this thing down here, which is going to be called the remainder, has degree less than this thing up here. Right? So I had to keep going on this step here because degree 3 here is not strictly less than degree 3 here, so I had to keep going. Right? Had there been an x squared or an x down here, pretty obviously degree 2 or degree 1, pretty obviously less than 3, so I'd stop. Yep. The degree of a constant. Anybody remember what the degree of a constant is? By the way, that's the way I keep writing x to zeros for constants, because, yeah, they're 0, okay? Because technically I can write this as 18x to the 0, degree is 0, so there it is, yep, okay? So that's one of the reasons I like x to zeros for constants. But point being is, this is degree 0, less than 3, so I stop, okay? Now, let's write this down. Start my integral, the original thing we had here, so x to the fourth minus 5x cubed plus 6x squared minus 18, all divided by x cubed minus 3x squared. Yep. Okay. Now, do all of our work right for a long division, okay? And this thing here will always end up being the stuff on top, whatever that is, x minus 2 in this case. Okay, there it is. Plus my remainder, so minus 18 divided by that thing sitting right there. Okay. So x cubed minus the 3x squared. Yeah, normally I'd put that minus sign out in front, but I didn't want you to screw up the minus sign later on down the road. Yeah, it's always plus the remainder. Okay. Okay, that's how that works. So again, folks, basically magic here. Yeah. So again, from here to here, magic, more commonly called long division. Okay. That's what you have to do, folks. Okay. When the new degree of the numerator is bigger than or equal to the degree of the denominator, you have to do long division. Okay. If this x to the fourth had not been here, degree 3 over degree 3, I'd still have to do exactly the same thing. Right? So basically, you have to do this anytime again, same degree or bigger degree, you have to long division to get down to this point down here, because now notice what happens. These first two terms here, I'm not going to insult you by asking if you can integrate those, because I know you can. Those are Calc 1, basic, simple Calc 1 stuff. Okay? I didn't do anything for those first two terms. This one, though, notice, though, degree 0 on the top, degree 3 on the bottom. Hey, guess what? I can partial fraction that thing right there. Okay, so you can't partial fraction right away, But upon doing long division, you get down to something that can be partial fraction. Okay, so let's do that. So, okay, we're good. So partial fraction is. Okay, so let's just strip that term out and we'll come back, put everything back together when it's all said and done. So minus 18. Don't forget to factor. Yep. So x squared can factor out, x minus 3 left over. Okay, everyone follow? Quote unquote. Okay. Now, that term's easy, yeah, linear term. Okay, so just a constant over x minus 3. This x squared here, folks, there's a couple ways to think about this, but I think the easiest way to think about x squared, and squeeze it down here, is to think of x squared as x minus 0 quantity squared. Okay, x cubed, x minus 0 cubed, x to the fourth, x minus 0 to the fourth. Okay, what that means for us then, folks, is that you don't think of this as a quadratic term. You think of one of those linear to a power. Okay, so what I have then is a over x, 1 for each power. X minus 0 is just an x, yeah? Plus b over x squared, or x minus 0 quantity squared, but again, don't need the 0. And then plus c over x minus 3, yeah? Okay, that makes sense, everybody? That is the best way to deal with this x's to powers, in my opinion. Okay, let's set our numerators equal, unless there's any questions, of course. Get our minus sign there. Okay, so least common denominator, again, it is not that times that times that. It is x squared times x minus 3. Yep. So a times what's missing? Well, I'm missing an x, and I'm missing the x minus 3, right? There we go. B times what's missing? Well, I'm just missing the x minus 3. There we go. C times what's missing? We're missing the x squared. Okay. Everybody follow / agree to this point. Yep, good. Okay, options here. One thing we could do, not hard to do, we could do the long way in this case, multiply the ax through here, multiply the b through, set coefficients equal. That's not terribly hard. You could do it in this case, folks, okay? But there's a small modification of my trick I want to show you here, folks, because notice that I could use my trick to very quickly get 2 of these, yeah? What's one good x I could pick just randomly to kind of use for my trick? That's a good one. 3 and 0, both. Yeah, good. So both 3 and 0. Let's go 3 first. That's the first one that was showing up here. So let's do a 3. Yeah. So minus 18. So 3 is going to knock out the first term. It's going to knock out the second term. Plug into the last one there. So 9 times the c. And of course, we're going to get that c is equal to 2. Yeah. 0 is another good one. So minus 18. Oops, negative 2. Yes, thank you. Thank you. Not working. Thank you. Yeah, and be careful, folks. Again, don't get too much of a hurry here. Yeah, thank you. But watch your minus signs. Yeah, really easy to do there. So thank you. Minus 2. Okay. Minus 18 there for the 0. The 0 is going to knock out the first term. It's going to knock out the third term, and so it's going to have a minus 3b. Should I get this one right this time? So b is a plus 6. Yeah. Yep. Yep. Good. 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 Everyone agree? Okay. Now here's where my trick breaks down. Yeah. Because 3 will knock out those 2 terms, 0 will knock out those 2 terms, but I have no way to knock out just b and just c and leave the a floating around. Okay, so my trick won't work anymore. But I was able to get all but one of my constants through my trick. Okay, and when that happens, I'm going to just go ahead and use my trick, get all of them that I can get, and then remember that, you know, I kind of joked when I wrote this up. I said we're going to pick numbers at random, and of course they weren't random. Yep. But I could pick numbers at random if I wanted to. I could pick, for instance, I don't know, 1. And that's not completely a random. I'll tell you why I picked 1 here in a second. Okay, but I could just pick 1 if I want to. Plug it in. So minus 18. Well, a times 1, that's a. 1 minus 3 is a minus 2. Yeah, so basically a times a minus 2. Yeah. Plus a b, 1 minus 3. Now that's b times a minus 2. 1 squared is 1, so plus a c. Yeah. Do you all agree I could do that if I wanted to? How does that help me? Because I claim that helps me. I know what C is, yeah. I can plug that in. Yeah, good, no, good, wonderful. I know what B is. I can plug that in, yep. So if I plug those in, see if I got this written down somewhere in my notes. Good, I do. So if I plug all that in, what I end up with is a minus 18 is a minus 2 times 8. I'll go ahead and move that minus 2 up the front. And plug your B and your C in over here, do your quick arithmetic, and you get a plus 14. Okay? Which then means subtract your 14 over, divide by your minus 2. I want you guys to check here, down below here. We end up getting that A should be a plus 2 if I did all my work properly. And there we go. Okay, so basically, folks, the trick can be modified if you need to, but it's usually not useful to modify unless you're in a situation like this where you can get all the coefficients but one, and then modify the trick a little bit to get that last remaining coefficient there. I will acknowledge, folks, that probably multiplying out, setting equal, probably a little bit quicker in this case, but you might want to check it out, see what you can get the same numbers if you do that. But I would suspect it's probably a little bit quicker, but I want to show you the modification of the trick. So, okay, everybody follow with that. Yeah. Okay, good. Oops. Oh yeah, minus 14. Sorry. Yeah. I apologize, folks. I flipped my yeah, should be minus 14. Thank you. In my notes that I'm following here, I factored my 18 out, so I'm having to translate negative signs in my head. So I'm sorry about that. I forgot about that. Yeah. Sorry. I knew I was being careful with the A. The A is right, but that 14 should be a minus 14. Yeah. Sorry about that. So yeah, I just have to translate negative signs in my head. I should pay better attention to my notes when I do this stuff sometimes. Okay, but thank you, Casey. Yeah, and Jordan both. Yeah, so thank you. Okay, so at this point, let's write down what we got. Yeah, getting kind of painful, but let's do it. So where's my integral? Is so x to the fourth. Write all this back down. Okay, we had an x minus a 2. Yeah, go back up here for a sec. There it is. So x minus 2, right there, plus the partial fraction that's got to do it here. Yeah. Okay, so plus, well, a is a 2 over x. Sorry, 2 over x, I think. Yeah. Yes, there we go. Okay, so a over x, b over x squared, c over x minus 3. Okay, so 2 over x plus b, 6 over x squared, plus c, so minus 2, so I guess minus 2 over x minus 3. X. There we go. All right, everybody follow / agree? Yep. Okay. Integrate that. It's a 1/2 x squared minus 2x. Again, that's just Calc 1. I'm confident y'all can do that. So there's those two. Next one, 2 natural log absolute value of x. Yep. Yep. There we go. Here again, remember this is really x to the minus 2. Yeah. So 6x to the minus 2. Integrate that minus 6x to the minus 1. Or if you want to get rid of the minus sign, minus 6 over x, take your pick. And then over here, of course, 2 natural log absolute value of x minus 3 plus RC. Okay. I think that was not as bad as the last one, I hope. Yeah. All right. So everybody follow with what I have got here so far. Yeah. Any questions? I'm actually done with this section. So you're capable of doing all your homework. Well, you'll be capable of doing all your homework once I make a quick comment. All righty, so I'm going to assume everybody's doing okay on this. All right, quick question, quick comment on your homework, folks. Number 12 on your homework. They say it in the instructions, but unfortunately, folks don't read the instructions anywhere near as often as they should. Use a substitution and partial fractions. Now, what that means, folks, is number 12 doesn't look anything at all like a partial fractions problem, right? Use a Calc 1 substitution. Look for a U substitution, right? Then once you do that U substitution, it will turn it into an obvious partial fractions problem. Okay, so make sure you do that. We can talk about that tomorrow as well, of course. But basically, just look for a quick little U substitution. Okay. And by the way, folks, in cases like this, your U substitution should be kind of tied to your denominator because that's what the U's are going to end up being. Okay. So look for a U substitution that'll make that work for you. Okay. And the numerator is, I'll just give you a hint for this right now as well. Your numerator is part of your dx. Okay. So there's substitution. Think about it, you'll be able to figure out what it is. Okay. We'll talk about tomorrow if you need to, but just use a substitution to turn it into a partial fraction problem. That's what they're talking about. Okay. So I'm guessing folks who've kind of worked on this ahead a little bit have probably got that part and probably freaked out a little bit when they saw that one if they saw it. Okay. So all right. So there is that. Okay. Now, remaining 9 minutes or so we've got here, folks. I think I can actually cover the complete next section. It's a very simple section. Well, I shouldn't say simple, it's short. Okay. Now, part of the problem with the material here, folks, is there are a ton of integration techniques, and unfortunately, sometimes it's not always obvious the best method to use for these things. Okay, so a little section here called integration strategy here. There are no practice problems for this one, folks, so be aware of that. This is just a quick, kind of a straight up kind of talking section. I'm not going to work any examples out of this section, just going to talk our way through real quick. Right now, the process I'm going to put down here, folks, is not necessarily set in stone. You don't have to follow this process exactly. Having said that, if you don't do steps 1 and 2 first, you're probably going to get yourself in trouble on occasion. Right? So you need to do steps 1 and 2 first. After that, all bets are off, okay, in some level. Now, step 1, and again, I cannot stress this enough. Simplify, 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 simplify. Yeah, okay, make it obvious there. Right? Now, again, what do we mean by simplify? We don't mean make smaller necessarily. We mean make simpler to do. Right? One of the integrals that causes students in this class no end of trouble all the time is the integral of cosine squared or the integral of sine squared. I see folks getting themselves tripped up on these all the time. Sine squared. Sorry. So I see folks getting themselves in trouble all the time with these folks, okay? But they're not as bad as they look because all you have to do is remember your half angle formulas. Cosine squared is 1/2 1 plus cosine of 2x. Problem gone, right? That squared is the problem. It's gone by use of a half angle formula. Sine squared is the same thing, yep. It'd just be a 1 minus instead of a 1 plus, right? So sine squared and cosine squared are actually really simple integrals to do, provided you quote unquote simplify. Right? And again, simplify does not mean make smaller, it means make simpler to do. Okay, does that make sense, everybody? Yes. Yeah. Yeah, it'd be the first step. And then because of the cosine squared, same thing. Use the half angle for the cosine squared. Yeah. 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 And keep in mind, folks, this kind of brings up the next thing. Keep in mind, of course, the little bits that I'm writing down here, yeah, are just quick little examples. Of course, there's lots of other things out there, of course, that it works the same way. Okay? So yeah, but keep in mind that simple examples here, not necessarily always going to be the only things, only examples I could do here. Yeah. Okay. Now, this next one, before I started doing this OneNote stuff here, I never kind of wrote this next one down as this. I wrote the next one down as Calc 1. Basically, don't forget your Calc 1, folks, okay? And that's really what I mean by this one here. See if a simple substitution will work, and by simple, what I mean is see if a Calc 1 substitution will work for you. Right now, in this class, when it comes to exams, okay, I'll tell you right now, if you can find a Calculus 1 way of doing an integral, do it. It's simpler. It's easier. I have no problem with you doing that. If you catch a Calc 1 way of doing them, great. Now, on your first exam, is that going to happen? Well, no, probably not. Okay. Second exam, on the other hand, I will guarantee there's going to be some Calc 1 integrals on there because they're going to be easier for you guys to do. Right? Unfortunately, though, a lot of folks tend to, because you're in a Calc 2 class, you tend to think we're in Calc 2, we have to do Calc 2. Not necessarily. Right? What do I mean by that? These two integrals right down here. Yep. Second one first. Calc 2 says trig substitution because it's a root, something squared minus number. That's trig substitution. Right? First one looks an awful lot like we could partial fraction this thing because x squared minus 1 can be factored as x minus 1 times x plus 1. Yep. So I could trig sub the second one. I could partial fraction first one if I wanted to. Or, let's use right here so it shows up a little bit more. I could just do a Calc 1 substitution. U equals x squared minus 1 and walk away and avoid a trig substitution, avoid a partial fraction. Yep. Right? I am not going to insist you use a particular method in this class, folks. Okay? If I were to put one of these two on the exam, folks, wouldn't, because they're sitting right in front of you. But if I were to put something like this on the exam, okay, the point of those problems would not be can you do partial fractions, can you do trig substitutions, it's be can you realize it's a Calc 1 problem. That's actually the point of a problem like that. Okay, so be looking for that. Now again, I won't do this to you on the first exam, but the second exam, you're definitely going to see some Calc 1 on there, but I see people try to do trig substitutions all the time on those problems, okay? We'll talk more about that when the time rolls around, but just don't forget your Calc 1. I know it's easy to do. You're in Calc 2, so you're focused on Calc 2, right? Don't forget your Calc 1. All right, next bit. Now, start thinking about Calc 2. Okay, now Calc 2 comes in. Once you've eliminated the possibility of simplification and eliminated the possibility of Calc 1 straight up, now start thinking about Calculus 2. Right now, some general things to look for. These again are not hard and fast rules. Okay, I can't write every possible thing down here. Okay, but is your integrand a rational expression? If it is, and you've eliminated Calc 1, yes, we've eliminated Calc 1 now. Right? If it's a rational expression, then I'm going to try partial fractions. I call these flashing red lights. Yeah. So a rational expression, polynomial divided by a polynomial, partial fraction. That should always just kind of scream out partial fractions again once you've eliminated Calc 1. Okay. We saw a lot of second part here in the first section we looked at. Do you have a polynomial times a trig function, exponential, or a logarithm? So a lot of those tend to be integration by parts. Right now, there are lots of other ways to do integration by parts that don't fall into those forms, though. We saw some of them on the homework, right? But these are kind of, again, the kind of the flashing red lights that say, hey, potentially integration by parts, okay? The third one then, of course, is just the stuff we did in the second section. Do you have products or quotients of sines, cosines, secants, tangents, cosecants, cotangents? Okay, that's just that second section that we looked at, okay? So then we'll have a name for those, but there it is, okay? And then the last one that I put last intentionally, of course, basically, getting underlined here, yeah. Are you going to be forced to deal with trig substitution? Okay, and again, folks, you only do trig substitutions if you simply have absolutely no choice. Okay, because those are just long, they're messy, they're complicated. Again, assuming, yeah, that we have eliminated the possibility of a calculus 1 problem. Okay, so you've eliminated that, and then maybe a trig substitution. Hopefully you don't have to, but again, I shouldn't say hopefully you won't have to. I think hopefully it'll make some sense here, folks. There is no way that I'm not going to put a trig substitution on your first exam. Okay, I'll tell you right now. Every technique we've looked at will be on your first exam. I'm not telling you anything that you're thinking you don't know. Okay, so you will see partial fractions, you will see integration by parts, you will see trig substitutions, you will see integrals involving trig functions. Okay, everything we've looked at will be there. Okay? All right, now this next one, because it's kind of what I hinted for a minute ago, folks. Okay. Again, when I'm writing this down in class for the OneNote stuff here, I labeled this one Calc 1. Again, okay. What do I mean by that? The first one was Calc 1 straight up. Can I just do a U substitution, do the problem, and walk away? Okay, that's what Calc 1 there. Now, Calc 1 here on step 4 is take something that looks nothing like what we've seen. Okay, We didn't see something like this when we were doing products of sines and cosines, okay? And we saw roots with trig substitutions. We definitely didn't see trig functions inside the roots and stuff. Yep. Okay. So this looks nothing like what we have seen. My hint, though, gave you a hint for the trig sub problem. I gave you a hint for the partial fractions problem. Look for a substitution that will turn it into a problem. Okay. So for this case, right here, yeah, I see a root here. I see something squared underneath the root. That again, flashing red light. Okay, that says trig sub potentially. Okay, but I don't want to do a trig sub looking like this maybe because it's not obvious trig sub. Okay, but because I can take that stuff under the root, I can write it as 1 plus sine quantity squared. Yeah, and say to myself, ooh, hey, let's try u equals sine of x. Because this stuff underneath here now becomes u squared, so 1 plus u squared, and what's du? Du is cosine of x dx. Hey, what do you know? Cosine of x times dx, right there, right? So with a Calc 1 substitution, I can take a problem that looks really unpleasant, and I mean really unpleasant looking problem, okay? And I can turn it into what's actually a really simple trig substitution. That is a really simple trig substitution, okay? Way simpler than any of them I did in class, okay? So watch your Calc 1, folks, okay? There is a trig sub problem that requires this. That one I just gave you a hint on for partial fractions requires this idea, right? So look for this kind of thing. Again, we'll talk about this tomorrow, I'm sure, for the trig sub for sure, and potentially the partial fraction one as well, right? So look for this kind of thing, right? Definitely takes a problem that looks really hard and turns it into a really easy problem, quote unquote. Yep, make sense, everybody? Yeah. Okay. I'm out of time here, folks, but basically multiple techniques. That's kind of step 4 up here, and 6 here. Try it again. If nothing seems to work, just walk away for a couple minutes, clear your head a little bit and come back and try it again and just try something different this time. Okay, so there we go, folks. I held you a minute late, sorry about that, but here we go. Okay, so this quick section, we're going to come back up and do help session tomorrow, start lecture up on Friday again. Okay, so I'll see everybody tomorrow.